There's one major problem with the code we've written so far, and that problem is that it's leaking memory. In this lesson, we'll talk about how memory is managed within an iOS application. Apple uses a mechanism called reference counting to handle memory management. Despite being a manual process, this is a fairly elegant solution with well-defined rules to ensure that we can achieve consistent results. Let's take a look at our code. Specifically, I want to run this code inside of a tool called Instruments, as this will help us define any memory leaks that we might have. We'll run the application just to make sure it's running as it was before. Everything looks good. Let's go up to the Product menu and select Profile. Go ahead and say Stop. And this is going to launch this tool called Instruments, and from here specifically we want to select this one called Leaks. We'll click the Profile button. This will start a profiling session. We can switch over to the Leaks tab, and you can see that it's detected some leaks in our code. Specifically, it's leaking an object called Artist and two instances called Album. So let's stop this tool. I'll actually quit it. Command Q to quit. Don't save. Let's go back and look at our code. So clearly we have some leaking that's happening in this code, but what do we do to resolve it? Let's switch to an illustration so we can get a better understanding of how this reference counting mechanism works. So reference counting is what's used to manage memory within a Cocoa application, so either macOS or iOS. But when an object gets created, it starts off with a reference count of 1. So here we've allocated a new object. Its reference count then gets incremented by 1 by calling retain. So another object wants to hold a reference to this object, it would call its retain method, which will increase its retain count by 1. That reference count is then decremented by 1 when we call either release or the auto-release method. These are two ways of freeing up memory. And then finally, when that object's reference count gets down to 0, the runtime invokes its dealloc method, and finally that object goes away completely. But you may be asking yourself a few questions. How do I know if I own an object? Why am I the owner? And if I am the owner, how do I free up its memory? There's a handy acronym to remember called NARC. And NARC stands for New, Alloc, Retain, Copy. So you become the owner of an object. So if you created an object by calling its new method, likewise you're also the object owner if you allocated a new object. So in the examples we've seen so far where we did alloc init, we called the alloc method, so we own that object. Alternatively, you might own an object by calling its retain method. You're saying you want to keep an instance of this object around, so you explicitly retain it. Or you may become the owner by calling its copy method. This is very similar to calling a retain method on an object, but with slightly different semantics. Okay, so it looks like I own an object. How do I free its memory? Well, memory can be freed by calling either release or auto-release on an object. So if we use the release method, that memory will be released immediately. So in this top example, we're creating an NS object and doing so through the alloc init method. And as soon as we're done with it, we're calling obj release. So this will immediately get rid of that memory. We can also say we're going to release eventually. So we've got the same basic object setup. We're creating a new instance of NS object, but this time we're saying object auto-release. And what auto-release does is it adds this object into what's called an auto-release pool. The application has got an auto-release pool available at all times. So by calling auto-release on an object, it adds it to that pool. And at some point in time in the future, that pool will be drained and that memory will be deallocated. Now, the point in time in the future is usually at the end of the event loop, so this typically happens very quickly. But these are both valid ways of releasing that memory. So once you've either released or auto-released an object, you should have no more leaks. So let's switch back to our code and see how we can resolve our immediate problem. So in this case, we can see we've created an artist. We've created two instances of album, but at no point are we releasing or auto-releasing these objects. Well, let's fix that. At the bottom, I'm going to say artist, release, and my two albums, I could say auto-release, but I'll just say release here as well. White album, release. So that way at the end of this method, when we're done using these objects, we're going to free up their memory. Let's compile this. And we're going to run instruments once again and see what's happened. So this time I'm going to hit Command I, and this will launch instruments. We'll select that leaks instrument again. And we'll keep an eye on leaks this time. And it took its snapshot, and we're seeing no more leaks. Let it run one more cycle. And once again, no more leaks. So this is very good. We freed up the memory that we were using. I'll quit this, Command Q, and go back to our code. Now I do want to point out one other memory-related problem that we would run into with the artist class. I'll switch back to artist.m. And if you remember in the previous lesson when we were implementing the setName method, I said I was kind of cheating. The implementation of setName is very simple and just happens to work given the nature of the type of string that we're working with, but that's really not a valid solution. Specifically, if I were to change to a different type of string implementation, this might cause various problems for us. So let's actually go back to main app, and I'll show you what those problems might look like. So instead of specifying this string literal, the Beatles, I'm going to actually create a string object to represent that value. And specifically, I'm going to create what's called an NS-mutable string. We'll talk more about this in a future lesson. I'm going to say NS-mutable string. Say NS-mutable string, Alec knit with string, and type the Beatles. And we'll replace this value with the string. So we'll compile that. And if I run it, Command R to run, we'll see the exact same output. That looks pretty good. But what happens if I, after setting the artist name, I release it? I'll run again and say stop. Well, it says artist. That's not quite right. And we also ran into some big crasher. So specifically a bad access. So all kinds of bad things happened here. Let's say stop. This time we won't release it, but we are going to modify it. So we're going to say string append string are the worst band ever. So some malicious hackers got in, hacked our string, and because this is a mutable type of string, we might run into all kinds of problems. Let's run the app once again. Oh my goodness, the Beatles are the worst band ever. So clearly we've got a data integrity problem as well. So how can we fix this? Let's click stop and switch back to artist.m. So clearly this superficial implementation we wrote before just isn't cutting it. So let's fix this. What we want to say is if name, our instance variable, is not equal to the incoming name, so this is a different instance of the string, we want to release the old string and then take the incoming string and make a copy of it. So that way we have our very own copy. Any further manipulation of that string from outside this class won't impact our class. Compile and save that. And we can see we have the same basic code here. We're creating this NS-mutable string with the name the Beatles, setting it, appending some additional information onto that string, and then logging the output. And we can still see in our console we had some ugly output happen the last time. Let's see if our new implementation fixed that problem. And there we go. Now we have a nice, safe version of that method. I now hope you feel more comfortable with manual memory management using reference counting. This topic can be a bit confusing when you first start using Objective-C, but overall it's a fairly elegant solution and with some practice becomes reasonably easy to use.